Hi General Math students. In this video we're going to use difference equations to model annuities. In particular, this video focuses on annuities in arrears. There's lots of different financial situations that can be modeled using annuities in arrears. The one we're going to focus on in this video is a bank loan, which is probably the most common type of annuity in arrears that you'll see. So I want to talk to you about the nature of a bank loan as an annuity in arrears, and I've got this example here to illustrate. So this graph shows the amount owing on a bank loan. So somebody has borrowed $1,000 from a bank. Okay, so a $1,000 loan. Now you guys would be familiar with the idea that the bank is going to charge interest on this loan. The person is paying back $200 each period, so $200 payment each period, we'll say, and the bank is going to charge interest at a rate of 10% per period. Okay, so those periods can be different lengths. It could be that the payments and the interest is calculated each month, could be each week, each day. This situation, we'll just say per period, we won't put any particular time length on it. Okay, so what typically happens is that we have $1,000 in this account. Okay, so this blue bar here shows the amount owing on this account as it's being paid down. So right now it's at $1,000. Now the bank will charge interest on that balance. So right now we have $1,000 in the bank, and the bank will calculate the interest by multiplying by the rate per period. So that 10%, we need to convert it to a decimal by dividing by 100, which gives 0.1. All right, so we multiply by 0.1, and that means that the amount of interest is 0.1 by 1,000, $100. So the bank will go and add that interest on. So now the balance is up to $1,000, and the person paying off the loan will pay off $200, so it goes down to $900. So there's the first period done. Then in the next period, the bank will calculate again. So now the balance is down to 900 by 0.1. So the interest amount is less this period. It's down to $90. So the bank adds that $90 on, and goes back up to 990, and then that person will pay some of that off, and it will go down to 790. They'll pay that $200 off. So you see that we start to get this situation that's a bit like two steps forward, one step back. The bank will add the interest on, and the person pays off some money, and then the bank adds a bit of interest on, and the person pays off another $200. So we're constantly getting this adding interest, paying off the loan, adding interest, paying off the loan, and eventually the person will whittle this down until the amount owed is zero. So that is the nature of an annuity in arrears. This is the difference equation, the way it's structured for an annuity in arrears. You can see that there's a common ratio and a common difference involved for these ones. So the common ratio, that R value there, that comes from the interest rate. You can see that here that interest rate is being added to 1. Okay, that's because it's an interest, a percentage increase. So we're adding the percentage rate to 100%, which 100% is equivalent to 1 as a decimal. The common difference is always subtracted. So the common difference is the regular payment, what's ever being paid off each period. It's always subtracted because that's coming off the loan. Over here we show the initial amount of the loan, so the original amount borrowed for the first term. I just want to question that, whether we would put a T1 there. I prefer to put a T0 for the notation here for the first term when it comes to annuities in arrears. I'll explain why that is later in the video. Let's look across at this example. It's a long sort of example. There's a bit to it, so fire up your TI Inspire, have that ready. Okay, so first off, we're told that there's a $12,000 loan and the interest rate is 8% per annum. So per annum means 8% per year. And the regular payment each month is $114.68. So the interest is calculated each month and added on each month. That is the length of the period. And the payment comes each month as well. Now, we're asked in Part 8 to find the monthly interest rate. So this is 8% per annum, 8% per year, but the interest is being added each month, not each year. So we need to find out what is the interest rate per month. So we take that 8% and we divide it evenly by the number of months in a year, which of course is 12. In this case, it's a monthly rate, so we divide by 12. It could be that the rate is calculated weekly. Then you would divide by the number of weeks in a year, 52. It could be a daily rate, so then you would divide by the number of days in a year, 365. But here we've got monthly, so we're going to go 8 divide 12, and that is our rate per month, 0.666 recurring. We'll go to 3 decimal places, 0.667%. Now that looks like a decimal, but it's actually the percentage. So later on we're going to still need to divide that by 100 to convert that to the decimal of that percentage. Alright, so we're going to set up our difference equation now. So the bare bones are that we have Tn plus 1 equals, and we have the rate there, but I'm just going to put Tn for now and the minus that's always there. So we'll put our common ratio and common difference in shortly. And I'm going to call T0 for our first term, and this is just about where I'm about to explain why I call that T0 and not T1. So first off, I'm going to fill in the common ratio in front of Tn. So I'm going to take the 0.667 and divide that by 100 to convert that to a proper decimal. So 0.00667 is what we get there. And then of course we add that to 1, so that gives us for our common ratio 1.00667. So there's our percentage increase with the interest per month. Then we're going to subtract the regular payment. Okay, so there's the first part. Now the initial balance of the loan is $12,000. So T0 is 12,000. Why do I want to put T0 instead of T1? Well, this loan is taken out at 0 months. At the beginning, it's at 0. So if we call this first term T0, that means the number of terms lines up with the number of months. If we were to call this T1, then 0 months would be at term 1, and then the number of months and number of terms would be offset by 1. So it makes our job a bit simpler if we call this T0. So I highly recommend that for annuities. Right, so we're asked to generate the first 4 terms of the sequence. We're going to go onto the calculator for this one, and we're kind of going to get ready for part D as well. We're going to do a bit of a graph at the same time. So let's get the calculator going, and we'll go into the green button there. So this one here, go into a green button for a spreadsheet. Okay, I'm going to put the months up the top here. We don't have to put the whole word months. Don't necessarily need that. Anything that you can remember would do. Amount in that one. So at 0 months, we have $12,000 on the loan. Okay, now let's fill in the rest. So we're going to go up to 10 months because I want to do a graph up to 10 months. I know there was nothing specified about that graph, but just to make it a bit more meaningful, we'll go to 10 months, and that will give us our first 4 terms as well at the same time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 months. And the amount. Now we'll go into this cell and we're going to enter a formula that involves our difference equation. So we push equals, and we put the common ratio 1.00667 times, and we put B1 because B1 is that balance, the opening balance. So we're going to multiply it by the interest rate to increase the interest, and then we subtract the regular payment. Okay, so I'll push enter, and there's the balance after 1 month. It's gone down a little bit. So now we want to fill this down for the first 10 months, but I don't want to have to type that formula in each time. So I'm going to go back up to this where I type the formula. I'm going to go across to menu. Then we go data and fill. So menu 3, 3. We go fill, and I just push tap down till we get to 10 months and push enter. And there are the balances. So there's our first 4 balances there. Okay, so we'll go and write those down, and then we'll come back and do a graph. So the first 4 balances are 12,000, 11,965.40, 11,930.50, and 11,895.40. Okay, now let's go and prepare a graph. So we're going to go into the home screen, and we click the pink button, that one. Okay, so I'm going to drag down to here and put months on the x-axis and amount on the y-axis. Okay, and there's a bit of a graph now. Our graph, I want it to go from 0, because you see here we're going to start with a 0 balance up to about 12,000 up there, right? And then from 0 months up to like 10 or 11 months, something like that. So I'm going to adjust this viewing window to do that. So watch this closely, because this will be really handy for you for other situations when you're graphing. I'm going to go menu and then window zoom number 5 and number 1 window settings. Now here we've got X min and X max, so that tells us where the x-axis starts. I want to start at 0, and I'll go up to 11. Just we cover all the data points we need easily. You could go up to 10 if you wanted, but 11 will do. Now same for the y-axis. The y min tells us where the y-axis starts, so we're going to start at $0. So remember, x-axis is where that's the number of months, and y-axis is the money, the amount owing. So I'll go just above 13,000 just to keep it so it's covered, and I push OK, and now we get that graph. Now you can see that the balance is going down pretty slowly. And the graph, it should be a curved graph. If we were to go on much longer, eventually it would get down to 0. But for now it's just a very slight curve to it. So we'll just show that on our graph. Okay, so just going to get rid of that stuff there. Our y-axis is already labelled. Our x-axis should say months. I'm just going to show these with a very slight curve for 10 months. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So going down very slowly. Just going to label 2 of these coordinate points. So I'll just hover the hand over that one, and it's 10, 11, 6, 4, 3. So 10 and 11, 6, 4, 3. And then I can just label the first point was 0 and 12,000. So remember to label 2 of those coordinate points. Okay, so let's then have a look at the next part, which asks us, when will this loan be paid off? Okay. So part E, how long will it take before the loan is repaid? So we're going to use the calculator to figure this out for us. We're stabbing in the dark a little bit here because we don't know how far we need to go to see when it gets paid off, right? Just going to go back to this original page. So get back on that one, the original spreadsheet that you had. And we're going to go really lots of months, lots and lots of, like over 100, right? So what I want you to do is go back to here. Now, I don't want you to have to type in 0 to 200 or something here. Let's get the calculator to do that for us. So we're going to just click on that cell, and I want you to click Shift. See that button there? Shift, and then down. And see how it highlights the first two cells? So that's Shift down. Shift and then down. Now the calculator is clever enough to understand that you can see us, we're starting to count up. We're going 0, 1, and it knows that it wants we want it to continue to count like that. But we have to tell it by saying Menu, Data, and we're going to do that Fill. So Menu 3, 3. Click on that, and then I tap down, and then just keep tapping and go for a long way. Keep going long way. Okay, so hold it down and keep going, and let's go miles into the future. Well, months and months. Let's go up to like 200 months. So sometimes you'll need to go a long way into the future to see. I'm not sure when it gets down to 0. So I'll just go over. 201 means there's, all right, so now I pushed enter and it counted it all up for me. Okay, so I'm going to go back up now and we'll fill this down as well. So we were at number 10. I'm going to, from here, just fill the formula down. In truth, you could choose any of these cells and fill down from there. So just once again, fill down with Menu, Data, and Fill. And then we're going to just click down. So we only need to choose one cell there, not 2 or anything fancy like that. I'm going to go right down as far as we went for those number of months. Let's see what number pops up. Okay, push enter. And we can see, oh, some negative numbers. That means the loan is past paid off. So we'll go down until we find out when it was at 0. When did it go negative? That's the key here. And oh, there it is. Okay, so if you go here at 180 months, they still owed $8.99. Right? So they needed another month, even though it was a very small payment. They needed one more month to pay it off. So it's not until it actually takes 181 months to pay off the loan, 181. So it's when it first goes negative, that's the number of months. So 181 months. Right, now part F, size of the loan after 10 years. 10 years, how many months is that? Well, of course, 120 months. So let's go back to our calculator and let's have a look at when we're at 120 months. So let's go to 120. There he is. And the balance was 5661.34. Okay, now part G. Check your answer to part E using a suitable financial maths formula. So what we're talking about here is annuities in arrears from the finance section of our course, or the finance unit. So at whatever stage you're at the moment, if you haven't looked at that formula yet, just leave this for now. But once you've looked at and studied the financial maths formula for annuities in arrears, it'd be good for you to come back to this part G and test that formula and see if you get the same answer as that one, which of course you should. Righto guys, so thanks for watching. Go ahead and check the description for the video and try some of these annuities and arrears questions modelling them using difference equations.